back. We are getting ready to jump into example 2. We're still in section 9.1. We just learned how to find that common ratio in a geometric sequence and then extend the sequence. So we're doing really, really well. So now what I want to teach you is how to actually find any term you want in any geometric sequence, okay? And there's a really important formula I want you to memorize. And it's right here, but I don't really like how I ended up typing that, so I'm going to rewrite it. And if you want to find any term, so a sub n is any particular term, what you're going to do is you're going to multiply the very first term in the sequence times that common ratio, but then that common ratio is whatever that term number minus 1. We're going to raise that common ratio to the n minus 1 power. So if you're looking for like the 10th term, then the exponent would be 10 minus 1, which is 9. So actually the 9th, so it's a one less than the actual term given. So what they have here, I'll just I don't want to dwell too much. This part, this is actually in your book, this part of your notes explains how the formula was derived, okay? Mathematicians like to show you how they got their formula. Why is the formula this way? Did somebody just wake up out of a deep sleep and all of a sudden go, aha, this is the geometric sequence formula? I don't think so. I'm sure somebody rationalized it, saw a pattern, and quickly created a formula for it. So let me just show you. So if your first term is a 3, we call that a sub 1. Your second term, to get to 6, what you do is you multiply 3 times 2 to the first power, okay? Because we know 3 times 2 is 6. To get to 12, we multiplied 3 times 2 to the second power. It's the third term, but it's the second power that we put on that common ratio. And so I'm hoping that you see the pattern. It's always 1 less than the term number. So I found the second term, but I'm raising my common ratio to the first power. I'm looking for my third term, but my common ratio is raised to the 2 power. And so that's where they came from. They said, here's my first term, 3. My common ratio is 2. It's always the number 1 less than the term number. So that's why they wrote that. So I just wanted to show that. I don't want to dwell too much on it, but I do want to make sure that you know I want this formula memorized. You don't need to memorize the formula from 9.1. You don't need that. This one, definitely memorize it. Okay, that's going to help you. It's going to be really good for you. All right, let's get to example 2. We're finding any term in a geometric sequence, okay? Any term. So they told us in this letter A, the first term of a geometric sequence is 128. Okay, stop right there. The first term, that's important, juicy information right there. The first term is 128. Remember what we call the first term? A sub 1 is 128. Okay, so we're going to call that first term. That's what they're calling it. So we're going to call it a sub 1 because that's what the formula says is the first term, a sub 1. And the common ratio is 0.5. So we're going to call common ratio R. Okay, because that's what the formula calls it. The formula calls it R. So R is 0.5. So now what they want us to figure out is, okay, what's the 10th term? So n is going to be 10. Whatever the term you're being asked to look for, that is n. So let me show you how to plug it into your formula. A sub n equals a sub 1 times r raised to the n minus 1. So what we're doing is we are looking for the 10th term. So that we're going to set that equal to a sub 1 is 128 times 0.5 raised to the 10 minus 1. So in your calculator, this is how it's going to go. 128 times 0.5 raised to the 9th. We already know what 10 minus 1 is. You don't need to put that in your calculator. You should already know that. So go ahead, let's key it in. 128 times 0.5. Use your roof button, raise it to the 9th power. and that 10th term is going to be a decimal, and it's 0.25. There's the 10th term right there. So if I took that term, I started with the number 128, and I kept multiplying all the numbers by 0.5, and I did that 10 times in a row, I would end up at 0.25. Well, I don't want to write out a number 10 times in a row. I just want to plug it into a formula and find it directly. So that's how you do one like that. Let me show you B. They gave us, now this time they changed their wording. Notice it says for a geometric sequence, a sub 1 is 8. They went ahead, instead of saying the first term, they went ahead and identified it as a sub 1. Perfect. A sub 1 is 8. And R is 3. Well, we know R is the common ratio. Find the 5th term. There's your N. Find the 5th term in the sequence. So, yeah, I could write it out. I could sit there and go, 8 is my first term, and then just literally multiply each term by 3 until I got to the 5th term. I could do that. Or I could just put it in the formula. I'm trying to find the 5th term. My first term is 8. My common ratio is 3, and I need to raise it to the 5 minus 1 power. So what's going to happen is, in your calculator, this is how it should look. You should put it in as 8 times 3 raised to the 4th power. And what is that 5th term in that sequence? You're right. The number 648. Great job. That's how you do it. That is how you do it. Let me show you C, just because it's slightly different even from A and B. What is the 13th term? So there's your N of the geometric sequence. And this time, they just gave you 4 terms in your geometric sequence. Well, logic says the 8 must be a sub 1. That appears to be the very first number in our sequence, so we'll call 8 a sub 1. And then we need to calculate the common ratio. So remember, what I told you is take one of the numbers, I'll take negative 16, and divide it by the number directly in front of it. Negative 16 divided by 8 is negative 2. And there's my common ratio. Okay? So what we're going to do is we're going to find that 13th term, and I'm going to start by multiplying the first term, 8, times the common ratio. Definitely put that one in parentheses because it's negative, especially since it's negative. And we're going to raise it to the 13 minus 1 power. So in your calculator, this is how it should look when you plug it in. You're going to do 8 times, and then in parentheses, put your negative 2 and raise it to the 12th power. And you should have a pretty large number. 32,000, my calculator says 32,768. There's your 13th term. Okay? And you could have sat there and started with the number 8 and just kept multiplying by negative 2 and done that 13 times, or you could just plug it into the formula. I think formula is a little bit faster. Okay, I'm going to leave letter D for you. You are looking for N. So what is N? What is a sub 1, which is your first term in your sequence? And what is R, which is your common ratio? Once you know those 3 things, plug into the formula and calculate it. Good luck with that.